Hey everyone, so today we'll be starting with recursion, a pretty famous topic. But although there are many tutorials on recursion, but still I feel for beginners, there is like we can as a content creators we can elaborate even in more deep, or if we can make it more simplified, at least for beginners, so that recursion, because I've seen many on the famous videos on recursion's playlist, still people find it difficult sometimes. If you give them a if you give them a solution for certain problems, they will catch it up. But for new problems, they always find it difficult to form a recursive solution. All right, so here it will be my take. Although, see, I'm not saying that there are no videos on it. There are tons of videos and better than me, but it's just my take on recursion. Let's see how it goes. So the primarily what we know about recursion is function calling itself. This is what everyone teaches, but don't fall prey for this definition. It's just like in on your college days, you would write an examination. This is just for that. Right now, don't consider this. So for me, what is recursion? If you see, there is a mirror. There is this person. There is this mirror. This person is name. His name is function. So this person is calling himself in the mirror. That's it. Function calling itself, not more than that. So forget about all this shit. I don't believe in function calling itself and all this. Let's see. Do you really know function before what is recursion and everything? Do you really know what a function is? I hope you are coming from when you are learning this algorithm and average data structure algorithm stuff. You are good in at least one of the languages: C, C++, Java, Python, and whatsoever. So there you should be knowing this concept of functions. So what a function does here, if you see, I'm having main function. Obviously main function is a caller in most of the languages. So this is specifically a C++ code snippet. I'm having this array a, size is 4 and 4 elements. What I want some of these, I want some of these elements, some of this entire array. So sum. So what I have done, see, to calculate a sum, of array, this is the way we can do. But what I have done, I have declared it in a separate function, here. See guys, and why we use function? For reusability. I'll come back to it later. Be with me guys, and have patience. This video might be a bit lengthier uh, on time, but you will get things. You will clear everything. Now see, again, I'm having an array b, which is having this time the size of this array is different. Earlier it was 4 size, now it is 3 sized, and as well as the elements are different. But yeah, it is an array. Again, if I want to calculate the sum, see guys, again, if I want to calculate the sum, do I need to declare any other function for this? Like, because see, the elements in this array might differ, size might differ, but the structure, it is simply an array. So the code that we earlier used to calculate sum for a, we can reuse that, because this code, what was this sum function doing? It was calculating sum over an array. All right. So you are here, if you have to calculate sum for b, we will again reuse this code, this function, we will reuse this. So what a function is used for? Function is used for code reusability. If certain function is performing a specific task, and if we know, like, this is an array, so to calculate their sum, this code is this function can be used. All right. And after this, see guys, the last thing about this function thing is, you see here it has some return type. So once function is done doing all his work, the final statement, which is the return statement, it will execute and return this resultant. This resultant contains what? The sum. It iterated over the array for its length, and it has res has all the sum. Now what it does, it returns res. Now return means what? Here, from wherever the caller is. Okay, see, sum was called by whom? Sum was called by this. So when the return res will be when this statement will be executed, res, the value, whatever the value is right here, let's say 10. So 10 will be printed here. So C out 10, which means 10 will be printed. Sum, so whatever res is here, let's say 15. So 15 will be here. So you know, right, this return statement, how it works, from where it is being called, this will directly go there. So this is what a function is. I hope this is a quick overview for that. Moreover, before starting like to go in depth of this recursion and everything, I just want to share a basic thing, like what a tree is. I'm not going in much depth of it, but what a tree is. Trees, like it is simply, you can say, if this sort of structure you can see, it is a tree. Specifically, it is a binary tree, but how it is represented. See, guys, every of these things, these circles, they're called nodes. All right, and the main, whatever you can see at the top, it is called root node. All right. So whenever someone says about tree, you don't know anything. You only know about the root node. This root node contains reference to its left child, right child. These left child contains again the reference to left and right. So you only know you only know about root node, nothing else. Then if someone says, someone gives you a tree in programming languages, he will only give you what, root node. All right, because from root node you will get to know about everything. Now how a node is represented, because root node, so we talked about a root node, but how a node is represented, generally what happens, a node is having three particular things, three things. First, a key means whatever value is present at that particular node, and two, we can say reference variables. In C++ we call them pointers. In Java and other languages you can consider them as reference variables. Left will contain reference to left node, left subtree, this subtree, which means this node, and right will contain reference to this node. All right, so this is in C++, you can declare with structures and classes as well. Here a snippet is for Java. You can see Java also just need to declare class and key, and left and right, the differences for them. All right, so what I wanted to share you guys, that when someone gives you a tree in programming languages, he or she will only give you what, root node. All right, now let's go let's go ahead. So let's say you are given this tree, given this tree, you can say this is a bigger one, and I ask you to calculate, to give me sum of all the nodes, to give me the sum of all the nodes for this tree. Now see guys, earlier in this array, what you did, 1 2 3 4, what you did, you iterated one by one, right? One step at a time you iterated, you kept on calculating their sum, you kept on adding their sum. All right, but here if you do the same drill of going one after another, so you see there are many combinations. See, from root you can go to left, 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 one way. From root you can go to right, right, right. See, I've written this. Then from root you can go to where, you can go to left, then right, then left. All right, in this way, if you go and iterate there, you have to write, like, see, because this is not a linear data structure, so you have to write manually many lines. All right, to calculate, to iterate over all these values, you have to write many lines. So just to get a sum of all the nodes, you will have to write like hundreds and more than 100 line of code. All right, and if the tree grows, your code will go exponentially. All right, so linearly traversing, linearly getting the sum is not a good idea. So what we say, see guys, let's write a function. I don't know how to write that, but see, I will write a function. This consider this a function. What is a function? You know, function is something that does certain piece of work. All right, here this is some function. It has this definition. What a definition, by definition I mean the work that it will perform. So here also, this is function f1. Do forget about its definition, but what if it does? It gives you a sum. Now how it gives you sum? Let's see in next slide. So here I've given the same tree. See what the tree, this is tree main. All right, I've just given a name for it. So this f1, what this f1 does, this f1 is having you, this is a function, and you give in argument. See here, like this, for the sum function you give argument, what you give argument as an array. You gave this array as an argument, and you said that calculate sum for this. Now for the see guys, for this f1 function, the argument is the entire tree. Argument is entire tree, and what you want to give me as an output, the sum for this. But as you know guys, what was the problem with linear way, going linear, because there will be many combinations of left, right, right, left, all the paths we have to cover. So linearly going is not a solution. All right, but as I said, what we know in this tree, what we know about this tree is, you know, the root node, because whenever I say tree, you should get that you know about root node. All right, you know about root node, which is 1. Now you don't know about, see, either you have the option to go to left subtree and go to right subtree and iterate, but I don't want to do that. What I will say, I'll create a new function. All right, if I'm having a power, I'll create a new function. See, be with me, guys, and things will be clear. Just be with me and have patience. See, what I'm saying, I have written a function f1 for this main, for this bigger for this bigger tree. Okay, to calculate, to give me the sum. What I will say now, I don't know. See, either I can manually go to left, right, all those things. I don't want to do that manually. I don't want to do that. It will take a lot of time. So let's see and write a functions for every possible thing. All right, every possible subtree. So what I said, for root node, I know the root node here. It is 1. So what I'll do, I'll create another function f2 and f3. F2 will contain what? The left subtree. See guys, F2 will contain this left subtree, for this one, a left subtree, and F3 will contain what? The right subtree. All right. Now what F2 have to do? F2 will again do the same task that F1 was doing. All right. What? It takes in a tree as an argument and will return and will give, see, I have written the plus. So once its work is done, once, see here as in this sum function, when the work was done, at the last line it returns something. So same thing will be here. Once the task of f2 is performed, it will return what? It will return the sum of these nodes. Same for f3 will again return sum for these nodes, and then you see I'm adding this to 1, the root node. All right, so if you pause this video right here, does this make sense, guys? Does this make sense that f1 was taking the bigger tree, the main tree? What it did, it splits the task. It says I won't calculate, because manually going left right it is a cumbersome thing. So what I did, it says that I am having a root node, I am having the information about root node, and I'll do only that. I'll add root node to whatever, I'll write functions for left subtree and right subtree, and I'll add their sum to this root node. Now see again, now f2 is in itself a tree. Look, f1 got a tree. Now f2 function, this function is also having a tree by itself. All right, as an argument. So again, to calculate sum, as we know, we want to go for left right, all those combinations. Again, this f2 will split its task into two other functions. It will say I want to have this entire thing left right. So we will create a new function f4 and f5. What it does, again, the similar thing that f1 did. You know the root node, the 2 for this f2, you know the root node. All right, and so f4, so after f2 assigns its task to f4 and f5. F4 will take the duty of calculating sum of left subtree, and f5 will take the duty to calculate sum of right subtree. All right, and when their task is done, they will return what? They will return the sum of left subtree and right subtree that you will add with plus, that you will add with 2, this root. All right, now see again, guys, f4, if you see this f4 in itself gets what? Tree as an parameter, tree as an argument. So again, as we know that, see here you are seeing there are only 3 nodes, but if the tree is bigger, you don't, as I've said guys earlier, you don't know about the child. You only know about root, you only know about root node. You don't know what is the depth of this tree, how many nodes are there. You only know about the root node. All right, so till the point it has root node, you will consider that it is a tree. It may have any number of nodes, but it is a tree. So right now also it is a tree. This f4 function is getting a tree. Again, to calculate this, it will assign its, see, it will say it will assign its work to, we will have to write a function f8 and f9. What it will does, what this function will do, they will so this 4, all right, this 4 is a root, as we already did. So 8 and 9, so this is also a tree. 8 and 9, see, tree with single node, but yeah, it is a tree. So it will say to f8 and f9, take my left subtree, right subtree, get the calculate the sum for them and give me, and I'll add 4 to them, because I don't want to do at every level these functions. They don't want to do that task. What task? Left right, all those combinations. They don't want to do that. Now again, see, f8 got a tree f8 got a tree in itself as an argument. It got a tree again, this f8 as well, although it is having only one node, this tree. But again, guys, as I said, that you only know about the root node. Now root node is present. This is 8. You don't know about, you never know about their childs. All right. So now f8 will say I am having my root node which is 8, f10 and f11. I'll write a function, and it will say whatever I'm having as my left subtree and right subtree, take them and give me their sum, because I don't want to even go and try that left right combination. Now see, after 8 guys, after 8 there was nothing, so we say that it has a null. We say that it has null, null. All right, in many languages it has null. And these at what I mean by this, at the final nodes it is pointing to nothing, so we will say it points to null. All right, it points to null. So here I'm representing an empty circle and it is null. So once you reach a null, which means there is no node, so right now there is no need to come, like for f10 will not call anyway, it will not call, because once you got null, so if a tree is empty, what is the sum? The sum is 0, so f10 will return 0, f11 will return 0. All right, now so f8, what f8 wants, the sum of its left subtree and right subtree. You are getting 0 0, you will add 8, so f8, so for this subtree f8 calculates sum as 8. Now f8 will return what? 8. f8 will say to f4 that your left subtree is having sum of 8. Similar way, this right subtree, its sum will also be calculated in the same way, and it is 9. Now f4, so what it does, so f4, you know this, see guys, 4, it the left subtree sum, right subtree sum, 8 plus 9, it will add to 4. Now after whatever solution, whatever sum you got for f4, f4 will return to what? Because f4's duty is done, f4 will return to f2. f4 will return to f2. In a similar way, everyone after their duty is done, they will return the values, they will return their values to their caller functions, the way we saw here, right? The way we saw here as sum. Once its task was done, who called it? Main function called it, and it will return the values. Now see guys, I know this may sound a bit tricky, but be with me a couple of minutes and these things will be clear. Now guys, see, if I have to write this value, if I have to write the function for this, obviously there will be a main function, and I want to write a function, let's say f1, which is a main function here, right? This, sorry, not main function, but f1 was taking the main tree as an argument. So f1 took the main tree, and you just write whatever f1 returns to you. And what is that? The sum of this entire node, sorry, the sum of the entire tree. All right, and this is node to root, so this is what f1 will get. So this is a C++ code snippet. So f1 guys, see what f1 does. Again, as we know, first of all, we need to see if node is null, you know, you have to return 0. All right, you can't go to left and right. But what f1 does, f1 assigns its duty to f2 and f3. All right, f1 assigns its duty to f2 and f3, and it says give me a sum of my left subtree and right subtree. I'll add it to my root node. And what it here the similar thing we are doing, it says what, f2, like it assigns a duty to f2. It says f2 give me some of left subtree, f3 give me some of right subtree, and I'll add them to my node key. And what I'll do, once you are done giving me that, I'll write a return in front of this. All right, now again we have to write f2 and f3 their definitions, then f3 calls multiple functions, f4 calls multiple, in this way. But guys, see, here comes a better like best thing. Till now we were writing functions. See guys, till now we were writing different functions. All right, for every duty, at every level, every subtree, we were writing different functions. But guys, now see the resemblance here. If you see this code here, this array, this was an array. All right, the size was different from this array, and the parameter and the values were different, but primarily they both were array. All right, so to calculate sum, do you wrote different functions altogether, like sum1 and sum2, or you utilized one common definition, this sum function, you utilized both for both array, you utilized this definition. All right, why? Because the structure of these arguments, this argument, it is array. All right, the elements may be different, the size may be different, but primarily they are array. So whatever the argument you are getting, it is an array. All right, so that is why you can reuse this. Now see in here, if you see what f1 was getting, F1 was getting a tree and it was returning sum. What F2 is getting, F2 is also getting a tree and it has to return sum. What F3 was getting, F3 was also getting a tree as an argument, it was returning a sum. All right, so F1, F2 and all other functions, their argument, whatever parameter they are getting in, it is tree, and whatever they are returning, it is sum. So the duty of all these functions, they are similar. The only difference is they are getting a decreased tests, or a decreased argument. What I mean by this, here the tree was larger, the difference is these trees are smaller in size, and we saw that earlier, that even if the array size is different, or elements are different, but it is an array, so we can use the same definition. So what I'll say, I won't write f2, f3, f4, f5 separately. What I'll say instead, f2, for f2 I'll say I'll copy the implementation of f1 function, because I already wrote f1. See, I already wrote f1. How I wrote? See guys, this is my f1 definition. All right, this is my f1's definition. I'm just saying that f2 and f3 what I have to write. So I already wrote what? I already wrote f1's definition. So I will replace f2 with f1. I'll again, for f3 as well, I'll say I don't want to write any new function, any new f3. I will use f1's implementation. For f4 as well, f1, because all these functions, their definition is same, because their parameter is same, their working is same. f5 f1, f6 f1, f7 f1. In this way, every function, they will use only f1. So what I mean by this, see, I will use a copy of, see, for these arguments I will use a copy of these f1 function. Why? Because f1 function, the duty that f1 function was doing, every other function is doing the similar duty. So why would I go and write a new function? I would just copy the implementation of f1. And see guys, see, all these till now, before f1 you were writing different functions. I know the number of calls are many, calls are huge, but you can see this structure. F1 was calling f2, f2 was calling f4, f4 was calling f5. So you are okay with this, right? Once f5 is done, it will return its value to f4. When f4 is done, it will return its value to f2. f2 is done, it will return its value to f1. Now what is happening right now? What is happening? See, f1 is calling to f1, f1 is calling to f1, f1 is calling to f1. So now what is happening? F1 is calling to f1, f1 is calling to this f1, this f1 is calling to this f1, so on. Now when this f1's work is done, it will return value here, it will return value here, it will return value here. And this is what? A function calling itself. See, function f1 is calling f1, f1 is calling f1. All right, so I hope you are getting this now. What this, see, whenever you get a recursion solution, people say think recursively. No, don't think recursively, think that they are, everything is a separate function. See, till now I hope these things, this was a bit lengthier to like accept, to digest, but if you see this with open mind, so what you can get, that these all functions were different, and so you won't get confused. But only when the name is same, let's say f1 f1 f1, then your confusion starts, that oh, every function is having the same name. But see guys, their name may be same, but they are different. It is copy. This f1 is not this f1, they are copy. See guys, I have copied the implementation. In programming languages as well, what happens when this f1, see, when this f1 was first called by main function, this f1 called f2, this is a memory or this is a call stack. All right, call stack. So this is how these functions will be called. F2 called f4, let's say f4 called f5, f5 called f8. Now once f8's work is done, it will return its value to f5, it will be removed. Now f5 when f5 work is done, it will return its value to f4. In this way, finally f1 will return to main. All right, so but now what is happening? If you see, now what is happening, it is f1 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 f1. See, these all f1s are different. All right, they are copy. These f1, these f1, these f1, they were copy of this f1, this f1. All right, but they're different. Think in a different thing, that they are different. No, they're not same, they're different altogether. And so, and this is how you may avoid your confusion. All right, now see guys, you don't have to work wait, we wrote that code, right? Now see, this f1, as I said, remove this f2 to f1, remove this f3 to f1. Now see, isn't this your main code that you want? Now f2 you don't have to write because we don't need f2 right now, so avoid this. Right now this is your recursive solution. This is your recursive solution right now, and you saw how we did that. All right, see, this f1 called it for its reduced test case for this f1 the left subtree, for this f1 the right subtree. Now if you directly get the solution for beginners, I'm saying if you directly get the solution, you can get confused that this f1 is calling f1. But see this, if you are having this bigger picture, you know that they all are different. They all are different. These f1s are like their state is different. All right, they're not same. So see guys, I know this may create a bit of confusion, but please, if it does, then revisit this video after some time, pause it. But what my aim was primarily, it's just to make you fearless on this recursion part. All right, and what I mean, see, many times I see people say think recursively. Don't think recursively, yeah. Right now, don't think, if you're a beginner, directly don't think on all those things recursively and everything. At the same time, it should not be the way that you write all these things all together, all these states. You don't have to write. For few problems initially you can write, but later on you should get a hang of it. Now see, when to use recursion. Now see, we used recursion here, right? But when to use recursions, you saw that if we were going for this piece of code, we have to write many lines. But here, if you see, we did the work in lesser lines. हमने सस्ते में निपटा दिया. So recursion is used to avoid writing all these many lines. And how is it possible? See, initially initially you were given this main tree. When you see that, see, whatever function you can write for this main tree, let's say we wrote remember we wrote f1. Whenever we can write a function for this main tree as an f1, you know that its child, see, this child and this child, they both are also trees. And the way f1 was solved, the similar way its child would be solved. So this f1 can be reused for them. So from the test case, guys, see, from the test cases, you will get the hint that this function, this problem is recursive. So apply recursion only when you see the problem's nature, it is recursive. What I mean by recursive is the bigger problem, if it can be solved, let's say with a function f1, you just have to observe that if I split it into smaller problems, can it be solved with the same function? Here you saw this, right? Here you saw this. The bigger problem was being solved with f1 function. Then you saw that smaller problems will also be solved using f1 function. And that is what we took advantage. That all the time we were calling same function, the copy of same function on a reduced data set. All right. So at one point we saw that it got reduced to such a length that nothing was remaining in the tree. And this is what we call base. This is what we call a base condition. All right, we will see this in another video, induction based hypothesis, but this is what a base condition is. And right now you saw what this recursion did. See, obviously it will use a call stack and it will create a copy of many functions, f1, but for every f1 you are getting a reduced size of test case, and you don't have to bother about anything, because this recursion, this main f1, see guys, this main f1 function, it called f1, it called for left, it called for right, it called for left. In this way, what recursion does, recursion calls for every possibility. See, recursion calls for every possibility. And here also, what we were doing, we wanted to calculate, we wanted to iterate for every possibility, root, left, right, all those possibilities. So and in this way you saw this recursion, it calls for every possibility. All right, and if it calls for every possibility, you don't have to write anything, because you can reuse these functions. All right, see guys, I know this may create a bit of confusion, but at the same time you should be free from this fear that recursion is something like pretty dangerous. No, if you see a test case, you just have to make sure that can I reuse the functions for whatever I wrote for main test case, the primary one, can I reuse the function or not? If I can reuse, I will reuse it, because we know that recursion, what we were doing, it was calling for every possibility, so we can reuse this f1. I hope you liked this video. Do let me know in comments if you liked it, and let's meet in another video then. Bye bye.